Okay, so adding and subtracting rational expressions. So we've been working with what rational expressions for the past week, pretty much. Adding and we know how to simplify a single rational expression by reducing everything that we can by factoring, canceling out, and then remembering that we still state restrictions. For multiplying, dividing, now there's two or more expressions you're worrying about. And so when you have two or more expressions to worry about, you have to make sure you factor everything. If division is involved, what's the rule? Division's involved.
Reciprocal.
Change it to multiplication and take the reciprocal of the second expression. And then it's the canceling game. And everyone, yesterday there's people who are saying, makes me feel so happy when things cancel, and that's nice. So in adding and subtracting, there's an additional little hiccup we have to kind of recognize. Because if we're adding and subtracting a rational expression, the analogy is adding and subtracting fractions. And so we know that when you add, back to grade 7, 8, 9, if I said add 2/3 plus 5/4, and I say I want you to add those fractions, the key is I can't add them at the moment, because you can only add fractions when the denominator is the same. And so we learned about we need to write both fractions with the lowest common denominator, and then I can add them by keeping the denominator and adding or subtracting the numerators. So the only complication now is instead of it being numbers, there's going to be expressions. But it's the same deal. We need to get a common denominator. It means the same expression needs to be in both denominators. Once that happens, I can write that denominator just once, and then I add and subtract the numerators. Okay? And then that might require me to do some expanding and simplifying. Going back to the beginning of this unit, we were adding and subtracting and expanding polynomials. We may be required to do that in these questions. Okay? So when adding or subtracting rational expressions, the first step is to write all expressions with the lowest common denominator, then expand and simplify the numerator. If possible, factor the resulting numerator to determine if any factors cancel with the denominator. And I would even say, like, before you even write with a common denominator, still try to factor. Maybe something reduces and your expression becomes a lot simpler to work with. Okay? So you might want to add like a star, always factor first if possible. Okay, always look for factoring first. Now, when you're stating restrictions, you don't have to worry about, you only have to look at denominators. And the nice thing is this is usually pretty easy to state your restrictions because the restrictions are going to be pretty obvious from step 1. Okay, so let's take a look at some examples. So the first example we've got here is monomials. So as soon as you see monomials only, you know that you're not going to have to worry about factoring. Factoring is not in the picture. So now I need to get a common denominator. So if it was 3/8 and 1/4 and 5/6, I would need a common denominator with the number part. Do you guys get I still need a common denominator for the number part anyway? Okay. Yeah. So 8, 4, and 6. What would be the number part that would be the lowest common denominator there?
24.
24, good. Now, how am I going to figure out the lowest common denominator part for the variable? And the key here is I need a denominator that x squared divides into, x divides into, and x cubed divides into.
X 6 over 6.
You don't have to go that high.
X cubed.
You just pick x cubed because the smaller powers will always go into a bigger power with the same base.
Yeah.
So that's basically your rule is you look at your variable part and you obviously have to have at least an x, but because I want to be able to divide into all three of these to divide into it, I need to pick the highest exponent. So 24x cubed is going to be my denominator. Okay? So just as 24, 8 goes into 24, 4 goes into 24, 6 goes into 24, we also have x squared goes into x cubed, x goes into x cubed goes into x cubed. So I've got my denominators. So now I'm going to write it 3 times, but eventually you may not need to do this, but I'm just going to be very clear this time. I want you to write each of those expressions with a denominator of 24x cubed. And it's the same rules you've used all along. If now my denominator is 24x cubed, whatever you did to 8x squared to get 24x cubed, you need to do the same thing to the numerator. So let's think logically. 8, to get from 8 to 24, you multiplied by 3. So I have to do 3 times 3 is 9. And then whatever you multiplied x squared by to get x cubed, what did you multiply x squared by to get x cubed? X. So I need to multiply the top by x. If I reduce that expression, I should get 3 over 8x squared, right? It's equivalent. Let's move on to the middle one. 4x. Whatever you do to 4x to get 24x cubed, you do the same thing to 1. 4 times what is 24? 6. X times what is x cubed? Good. And now 24x cubed from 6x cubed. To get from 6 to 24, multiply by 4. Oh, but there's already a 5 there, so what do we need? 20. And then x cubed to get to x cubed. You don't need anything more. So that's your, but you guys get that's equivalent. And when I gave around your show what you know, I mentioned this to several people, but I'll just reiterate to everybody. The equal signs in front of each of your steps is indicating equals line above, equals line above, equals line above. It's part of your solution, so you need to keep those equals signs shown. So I now have this. Is everyone okay that I am now okay to put it as a single expression because they all have the same denominator? I can put 24x cubed as the single denominator. Now when I put my numerator together, you know, they're monomials. Maybe I'll put it in order of degree, just for optics, make it look a little nicer. So I have 6x squared, or sorry, 9x, 6x squared, and 20. What would make sense to put first for our proper form for polynomials? Yeah. So 6x squared, and then would come 9x, there's no sign, which indicates it's positive, plus sign, and then minus 20. Now, what would happen now is you should try and see if this is factorable. And of course, we had to pick this one that's not very pretty. Is there any GCF? 6, 9, 20, no. So the only thing you can kind of do here is do a quick check of your sum and product. Because this would be one we're doing guess and check. I'd be a little wary of doing it because there's like a lot of combinations, right? There's 1 and 20, 2 and 10, 5 and 4, 6 and 1, 3 and 2. So for the 6, there's 1 and 6 and 3 and 2. For the 20, there's lots of options. And you can play it out. Or it might be faster to even see if it's even workable by just looking sum of 9, product of 6 times negative 20 would be. Here's the thing I want to put in your minds right now. I'm going to say 80 to 90% of the time, the numerator will not be factorable. Meaning you're done, basically, at this point, other than we haven't stated our restrictions yet. Okay? Let's just do a quick double check. So think of pairs of numbers that multiply to negative 120. What's our list, basically? And we know that 1 and 120, they're way too far apart. What would come next? 2 and 60. 2 and 60, too far apart for 9. 2 and 60, too far apart. What would come next? 3 and 40. 3 and 40, still too far apart. 4 and 30, still too far apart. How about 5? 5 times 24, so that's 5 and 24, that's 19 apart, so still too big. Does 6 go into 120?
Yeah.
Okay, so here's how you know you're done. 6 and 120. 6 times what is 120? 6 times 20. What's the difference there? 14. Do you see where I'm going? I'm just trying to figure out, are any of these combos going to give me 9, right? So I'm already at, so what we're at 6 and 20, and that's a no. Do you think 7 is going to work?
No.
Is 8 going to work?
Yeah.
8 and 15?
Yeah.
But right now, if I do the difference, it's a 7.
Yeah.
I've already skipped over 9. Do you get that this is not factorable?
Yeah.
As soon as you like too far apart, now I'm below the number I want apart. That's your
below 9 in this example. That's how you know.
Yeah. You know you've exhausted all the pairs as long as you haven't missed a pair. But and to be honest with you, on the test, is it going to be this? I don't want you to spend like 5-10 minutes checking to see if it's factorable. You know what I mean? I'd rather it be a little bit more obvious. But in this case, that's what it is. So we know it's not factorable, so we're actually done, other than the fact that we're going to go back here and say, what is x not allowed to be? For monomials, x is not allowed to be 0. We could have stated that as soon as we had the common denominator, we could have stated that. So the one thing you might notice here, the one thing that's absent is the canceling. Canceling isn't going to happen here. Very rarely will canceling happen here.
When would it happen?
If this is factorable, and you can cancel it out, right? Okay, yeah. Let's do the next one. So 3n over 2n plus 1 plus 4 over n minus 3. So again, it's slightly more complicated. We've gone into binomials now, so it's not as straightforward, but still, is there any factoring that I need to do here? Or is everything as simplified as you can get? Or if you look at each of them separately, you can't do any factoring, right? There's not quadratics that we can factor or anything like that. Okay, so I now need a common denominator. So here is where it's going to look a little strange, but this is like I want you to think of this as the denominator 2n plus 1. That's a package that you can't split that up. 2n plus 1 is the denominator of the first expression. N minus 3 as a package is the denominator of the second expression. I need a denominator that both of those packages will divide into. What do you think you have to do? I'm going to go back to our numerical example from the beginning. Remember my 2/3 and 5/4? What's the common denominator there?
12.
Why are you picking 12? Because you know 3 goes into 12 and 4 goes into 12. You need a denominator, in this case, you need a denominator that 2n plus 1 goes into and n minus 3 goes into. Guess what you just have to do? Multiply them.
Okay.
Then you know, if you have the product of 2n plus 1 times n minus 3, will 2n plus 1 go into 2n plus 1 times n minus 3? True. Will n minus 3 go into 2n plus 1 times n minus 3? Yeah, there's the combo that we cancel, right? So that's what happens. Now, here's where, to save some room, is everyone okay? I'm going to just write a single expression right away. Or else you have to do 2n plus 1 n minus 3 plus 2n plus 1 n minus 3. You're going to have to do it like twice. Which you can, but I'm just going to do it once. 2n plus 1 bracket n minus 3. That's my common denominator. Okay? Now, the first expression already has a 3n, so I'm going to write it. But I'm not done because I want the 3n to be adjusted so that it matches the denominator of 2n plus 1 times n minus 3. So what do you think I need to do to the 3n? Multiply by the piece that was missing, n minus 3. Everyone cool?
What do you mean the piece that was missing?
Okay, maybe I'll go. Okay. I've changed my mind. Okay. I want the first expression to be equivalent to the expression I'm about to write. The denominator of the first expression is now 2n plus 1 times n minus 3. Okay, so what do I have to do to 3n to adjust it so that it matches with this denominator? And everyone, I'm going to do this just temporarily. Don't do this. don't do this, but hey, it's equivalent to the original. Because the common piece would cancel out and I would get the original back. Right? Does this make sense? Do you get that why that would be a useless step though in your process? Like you'd be in this infinite loop of I'm gonna multiply by n minus 3, cancel, I'm gonna multiply by n minus 3, cancel. Like you won't go, you can't go any further than that. You can't do anything with that. The whole key is to do that step. And now the second expression has a 4 in the numerator. What do I have to multiply 4 by? So I get the denominator 2n plus 1 times n minus 3.
2n plus 1.
Yeah, 2n plus 1. Okay. Now you can maybe see where I was trying to go. I wanted to just do a single denominator all at once, and then just deal with the numerator adjustment. But now that I have it like this, I want my denominator to be this. So I have to have 3n times n minus 3 plus 4 times 2n plus 1 would be in the numerator.
Yeah.
I could copy it down, but do you guys get what I really want to do is that's not factored. I'm gonna write it down in this case, but I want you to understand. I want everyone to understand you are not done right now. If you go and finish, you would be not getting full marks. You'd be getting like 2 out of 4. Okay? Because factored form means everything's factored. The denominator is fine. The denominator is factored. It's a product. Is the numerator a product? The numerator is a sum. Yes.
Oh, never mind.
So what you need to do now is you need to make the numerator a one expanded polynomial. Brackets don't mean, as soon as you see brackets, it doesn't automatically mean it's factored, right? There's this plus sign here. It means it's not factored. So what you need to do is expand the 3n into the n minus 3. You're going to expand the 4 into the 2n plus 1, collect your like terms, see what polynomial is in your numerator. If it's factorable, great. Try and factor it, see if you can cancel stuff out. If it's not, you're done. Okay? So let's see what happens when I expand. Before I do that, though, I want to put a word of caution right now because I've seen several students do this. They get to this step, and then they say, hey, do you get why that's illegal canceling?
Yeah.
You can only cancel when everything's factored, and we just said the numerator is not factored, right? So don't do that. You can only cancel out if everything in the numerator and denominator is in factored form. Products, okay? So if I distribute 3n times n, 3n squared, 3n times negative 3, negative 9n. Positive 4 times 2n plus 8n, positive 4 times 1 plus 4. All over. Don't expand denominator. Don't expand denominator. Don't expand denominator. Leave it factored. Factored, we like it. If it's factored, don't make it worse. Okay? Can I clean up my numerator slightly?
Yeah.
3n squared, negative 9n plus 8n. Good. And then 2n plus 1, n minus 3. Okay. Now, is there a potential that that numerator is factorable? So shall we do the check? We're going to check, see if it is factorable. Okay. 3n squared minus n plus 4. So do you guys want to do the sum and product check like we just did in the previous one? So the sum you'd be looking for is negative 1. The product you'd be looking for is positive 12. As soon as you see your product's positive 12 and your middle term's negative, they both have to be negative for this to be factorable. You have to have two numbers that are both negative that fit this pattern, right? So as soon as you have that, this negative 1 is going, yeah, I don't think so. But let's check it out. What are numbers that multiply to positive 12? So we're only going with negative options. So there's negative 1 and negative 12. Do those add to negative 1? Negative 2 and negative 6. Do you already see, like, you're never getting negative 1 because you're always going to have numbers bigger than 1. You can't add two negative numbers bigger than 1 and get negative 1. Right? Now the only other option is negative 4, negative 3, it's negative 7. So I want you to understand the fact, like, if this is a negative 7, factorable, go for it, right? Factor it. But because it's a 1, it's not factorable, so we're done. We can't go any further. There's no common factoring, so that's it. Again, go back to stating the restriction, though. Do you guys you knew what the restriction was at the very beginning, because there's no extra restrictions that have shown up in this process. Yes?
Do we have to write down the lowest common denominator?
You don't have to do that. I just did it in the first. Sometimes it's easy. It's for monomeals. It's easy. It's sometimes helpful.
Yeah.
You don't have to do that. Let's state our restrictions. What is n not allowed to be?
Negative 1 over 2.
Negative a half or
3.
3. Okay. Okay. All right. Let's do C. Okay. So in C and D, things get slightly more complicated. So please, I missed. I didn't take my attendance, but they're all here. Yeah. Okay. Thank you. So his last two, there's going to be an extra step required or an extra few steps required. So let's look at C. 2t over t squared minus 1 minus t plus 2 all over t squared plus 3t minus 4. This time, you can do a little bit of prep work, right? You look at this and say, hey, I can do some factoring, right, of the denominator. So what happens if I factor the denominator? T squared minus 1 would become?
T plus 1, T minus 1.
T plus 1 and times t minus 1. And then the second expression, t squared plus 3t minus 4 becomes t plus 4,
Yeah.
t minus 1. True?
Yeah.
Okay, and then just copy the numerator. So just to prove to you that you can do it now versus later, what is t not allowed to be?
1, negative 1, negative 4.
What, so negative 4, negative 1, 1?
Yeah.
Okay, good. All right. Now, here's where we want to do this correctly, and we want to do it in the easiest way possible. So I'm gonna do a numerical analogy right here, just to kind of, because I want you to visually see what's happening here. If I said, I want you to figure out what, let's see, 11 twelfths minus 3 twentieths. I said, I want you to figure out what that's going to be. Okay? So, yeah, like you could treat it like we did the first example and say, well, I'll just need to multiply those denominators and that will be a common denominator. But the key there, it wouldn't be the lowest common denominator, right? And I'm going to show you something that we never really did well, you might have done it in elementary school. 12, what if you broke down 12 into its factors? What would be two factors that multiply to give you 12? Most of you would jump to 4 times 3, right? Would you all agree that's the same?
Yeah.
Okay. What would happen? How about 20?
4 times 4.
Okay. So I want you to, do you see an analogy to what I've just drawn here numerically and what we have in our algebraic expression? Okay, because do you guys get that just multiplying 12 times 20, yeah, that's a denominator that will work, but is there a lower denominator, a lowest common denominator? The key here is there's already a 4 in common. I don't have to multiply 20 by 12, because the 4 is already part of the 20. In order to get the common denominator, I really have to multiply by 3, meaning 60 would be the lowest common denominator. So basically 4 times 3, if I just multiplied by the extra factor, that would work, because the 4 is already in common. Do we agree, 4 times 3 times 5, that's the lowest common denominator there. Because will 4 times 3 go into 4 times 3 times 5? Yeah. Check, check, right? Will 4 times 5 go into 4 times 3 times 5? Check, check. The 4 gets counted twice, but that's fine. So what I'm trying to get at here is, in our algebraic example, do you get that there is a common piece? You don't need to multiply by the common piece. It's already there. It's already in common. You're only going to have to multiply numerators by the piece that's missing from each expression. Everyone follow? So like,
you keep a t minus 1 and then you just add a t minus 1.
so like, for instance, so what will be the lowest common denominator? Do you guys get, in order for this first expression to work, t plus 1 times t minus 1 needs to be in the denominator. This one, t plus 4 and t minus 1 needs to be in the denominator. So in order for all the conditions of both those to be true, what needs to be my denominator? T plus 1 times t minus 1 times t plus 4. Do I need another t minus 1?
No.
It was already there. You don't have to double count. And do you get that that makes your life a lot easier if you pay very attention to this? Because the matter of, do you want to multiply 2t by just t plus 4, or do you want to also multiply it by this?
Yeah.
And if you do that, you guys get, now we have like cubics, and it's going to take you a long time to simplify. Whereas we know that we're all should be experts by now at expanding things that look like this.
Yeah.
Okay? Is everyone following the logic here? So here's where I'm going to suggest to you, just to save you a bit of time. As soon as you see you're about to write this with a common denominator, I was about to in the last one, and you guys kind of went, what's happening? So hopefully you guys are seeing this here. Do we all agree that the common denominator is going to be for the first and the second? It's the same, common. And it's going to be, you just told me, t plus 1 times t minus 1. So it's the denominator of the first, and then what extra piece do I need? The t plus 4. Okay. Now, I go to my 2t, and what is the piece I need to make it so that if I did this piece divided by the denominator, it would be equivalent to 2t over t plus 1 times t minus 1. I need to multiply by the missing piece, right? The t plus 4 minus. Now, I have a t plus 2 in the numerator. Already I'm getting a little antsy right now. I'm like, ah. You need to put it in brackets, or else things are going to go kooky on you. You're going to lose a sign, or signs are going to go wrong, or you're going to think that you're distributing only the 2 or something. So if there's anything that's in the numerator that's more than a monomial, put that piece in brackets. Remember, your numerators and denominators, consider them packages. They go together. Okay, like in Greece, right? They go together. Right. Yeah, that's what I remember. Okay. I'm not done now, because this piece, the second expression, is missing a piece. What's the piece missing?
Plus 1.
So that's the piece I need to multiply this numerator by. So I just want to illustrate this is perfect. This is perfect how it is right now. Again, you cannot go cancel crazy. Remember, you just purposely multiplied by these two things. Don't do this. Right? First of all, it's illegal. Secondly, you're just undoing what you did, and you're doing it wrong. You're undoing what you did wrongly. Like, it's bad. This is not good. Okay? But like, I know you guys even said, I love canceling. It's so great. But you got to recognize for adding and subtracting, it's going to be a very rare case where canceling is actually going to be possible. Okay? So don't do all that stuff. So this is what you got. Again, what did I say? Never expand the denominator. But I have to expand my numerator because right now it's not factored and it's not expanded. So I at least need to get it expanded. Okay? So leave the denominator alone. And please, okay, I'm going to say it right now because there's going to be some smart person here that thinks, I'm just going to do this. Ditto. You can't ditto. You can't ditto the denominator. Okay? Or do... You can't like cheat, like don't get lazy and just say it's the same, okay? You have to do the copying. I know it's a little tedious, but c'est la vie. So, okay, copy, oops, make sure you copy it right. Copy. And this is why I tend, I don't know how many of you have started doing this with your T's. You make them look so that you have to distinguish them for yourself between T's and plus signs.
Yeah.
So one way to do it is to put a tail on the T. But you don't have to do that, but it's whatever works for you, right? Some people like to handwrite t's. Okay. Okay, so there's my t's. T plus 1, t minus 1, t plus 4. So now let's expand 2t times t plus 4. 2t squared, 2t times positive 4 plus 8t. Now, here's where you have to be super careful. And again, does everyone see the importance of putting brackets around that expression that we put first? Like, I think if you guys all saw minus t plus 2 bracket t plus 1, if I just said expand that, do we all agree you're doing a completely different thing?
Yeah.
Okay? So, you're subtracting t plus 2 as a package times t minus 1 as a package. So, this is what would be my suggestion to you. Again, your comfort level. I would like keep in mind that there's a minus there, and do t times t is t squared, but I need to write negative t squared because I'm going to be distributing a negative each piece here. Negative t squared. T times 1, positive t. Positive 2 times t is 2t, so t plus 2t, 3t. But I'm going to write minus 3t. And then positive 2 times 1 is positive 2, but I'm going to write negative 2. You get this part? This is where most students will mess up a sign here, so just be extra careful. What you're doing, basically what we just did there is we expanded and then we distributed in the same step. That's what just happened there. Okay? Because there was a minus in front. I expanded this and then I distributed the negative to what was there, to what I expanded. Again, you're going to have this scrap paper. We're going to do all your scrap work, all your factoring scrap work. So if you need to do that on scrap work and then just show me it on your paper, that's fine. Okay. And now, collect the like terms. 2t squared minus a t squared. T squared. 8t minus 3t plus 5t. And what's left? By now, you guys should have like an inkling that when I look at that numerator, I'm feeling the non-factoring, not non-factorable. Right? As soon as you see a C value that's way, way smaller than a B value, it's a big indicator that there's not going to be two numbers that work. But just even think, what are the only numbers that multiply to 2?
1 and 2.
1 and 2. 5's not an option, so not done. Okay? But again, so that's your final answer, done. This is your final answer. But we didn't state restrictions. Oh yeah, we did. Sorry, luck. We did it. Okay. Again, that's always one of those things to make sure you state restrictions. The way the test is going to go, guys, it's pretty much your communication mark. Your entire communication mark is basically going to be, did you state your restrictions for all your questions?
How much is the restriction when it's just one part?
So it depends. Sometimes I might assign 2, but usually each restriction is a half. Does that make sense? Typically. Sometimes,
So a lot of them, like more than 2, like sometimes there's like 4 restrictions.
Yeah. So usually what ends up happening there is I take off a half, but if you get one, I don't get. We'll talk about how I'm going to mark your restrictions when we get to that. When we get there, okay? Yeah. Okay. So now let's look at the last one because looks fun, right?
Yeah.
Basically, your thinking question on the test is going to be this. Thinking is going to your thinking questions on the test are going to be one of these, and I'm saying only one of these because this is going to take a little bit of time to kind of figure out. It's a combination of both, and it's M's and N's, 2 double letters. I know, fun, right? And there's some like complex trinomials, so you have to do some decomp or some guess and check.
Oh, yeah, there's factors.
Okay, so basically your thinking on your test is going to be one of these and a couple of grouping factories. That's basically your thinking on your test.
So no word problems.
Correct, no word problems. So, now, here's the trick with this one. So, I have a rational expression minus a rational expression divided by a rational expression. Okay, so I have a mixture of operations. So not only do I have to do the appropriate strategy, I also have to remember I have to also kind of keep in mind what do I do first.
A factor? That matters.
So when you look at this and you're dealing with this, what do you think you're going to be dealing with first? The division. Okay? And before you even deal with the division, you're actually going to do something even before that. You're going to do the factoring. Maybe some stuff's going to reduce. And it's actually, if you're going to divide first, that's actually beautiful because maybe the dividing part will make this a much simpler expression. The key is you got to do it right. Because if you mess up here, then you guys get one mistake here can lead to horribleness later. In terms of if you factor something wrong and then there's not something in common that it's not really in common, you can go explode. I will follow your work though. I'm not going to just give up and go, I don't know, 0. Like I won't do that. Okay. However, you just have to keep in mind that, you know, if it gets too complicated, you might be like, maybe I made a mistake. I better double check stuff. Because I'm not going to put something that's going to take, if you're like, I need 3 extra pages to finish this question, it's probably not the right strategy that you use. So anyway. Let's give this a whirl. So let's start factoring. Is there any factoring to do with the first expression?
No.
And this would be also a situation where I would, if anything was n's and then m's, I would do the switcheroos at this point as well. But everything's in alpha order in this, right? Yeah. So 5m minus n over 2m plus n. Do you get that this expression here is going to be off limits? This expression is going to be off limits until we've done the dividing. Yeah, I got the letters inside, so. Yeah. Sure. Yeah. Thank you. Okay. Okay. So now, I'm going to factor this. So 4m squared minus 4mn plus n squared. Now, before you jump, like, first of all, does that fit any of our special patterns?
Yeah.
Is it a perfect square trinomial?
Yeah, it is.
Because 2m and 2m, right? 2 times 2 is 4, and 4m squared is a perfect square. 2m would be the base, or the square root, and then square root of n squared is n, and then the sign in between would be minus, and then just do a quick check of what the middle would be. The middle would be this times 2, right? This times 2. What would you do? What would happen if you did that? You would get negative 4mn, which is what we've got. So my question to you is: you can do this squared. Or you can do 2m minus n times 2m minus n. Shall we leave it as factors again just for easing of canceling? Okay? So I'm going to write this a bit tinier. So 2m minus n times 2m minus n all over. How about 4m squared minus n squared? Does that fit any pattern?
Different squares.
Okay, so it's a 2m plus n times a 2m minus n. And now I've got divided by, so 6m squared minus mn minus n squared. So this is the only one that maybe you'd go to your scrap paper to figure out, right?
Could you change it to like multiplication right away?
Yeah.
You can. You just got to be careful. As long as I'm fine with it. If you want to go but then you just got to remember that you did that. Don't do this and then you forget to do the flip, or else you're gonna have problems. So if you do that, that means that I'm actually factoring the denominator right now. And what would happen if I factor 3m plus 15n? I would just take out a 3m plus 3n. And then for the denominator, 6m squared minus m minus 1. Do you get that? That's the pattern I need to factor.
It's 5.
On the top? Yeah, because it's 55, which we divided by
Oh, okay, sorry, my bad, thank you. Okay. So is everyone okay that this is how I deal with patterning for my complex trinomials? I drop the n to make it less complex to look at. I need to find the pair that works here. The numbers are small enough, I'd be doing my guess and check. I go, okay, so 6. My options for 6 are either 1 and 6 or 3 and 2. What are my options for negative 1?
1 and negative 1.
1 and negative 1. So 1 and negative 1. So again, the way this works is, I'm going to see if I get a negative 1 when I multiply and add or subtract, right? So multiply and add. So if I do 1 times negative 1 plus 6 times 1, I would get 5. So this one's out, and I know that the other order will be out too, because they would just give you negative 5. Yeah? Does everyone get this? So this one's out, so it can't be that one. So let's try this. Negative 3 plus 2. Negative 1. So this one works. So now I know that this factors to 3m plus 1 and 2n minus 1.
With their ends. Yeah.
Yep, with n's. You are so right. And that should be an m. Oh gosh. Okay, let me try that again. 3m plus 1, but really it's an n. And then 2m minus 1, but really it's an n. Okay. So I have successfully factored at this point. And you've also done your taking the reciprocal. Shall we, before we go any further, get our restrictions out of the way? Yes. Okay. So shall we restrict? Let's restrict in terms of m's. What is m not allowed to be? So anything that causes a denominator to be 0, and what other piece do we have to look at?
The top of the top.
This one right here. We have to check to make sure that this is also not 0. So let's go scan across. So what would cause m to be 0 here?
Negative n over 2.
Negative n over 2. What would cause m to be 0 here?
Negative
Same thing. What would cause m to be 0 here?
N over 2.
What would cause m to be 0 here?
Negative n over 3.
Negative n over 3. What would cause m to be 0 here? Already got it. And over 2. What would cause m to be 0 here? This is the only one that's not a fraction. Negative 5n. Yeah?
Okay.
Negative 5n plus 5n would be 0. Negative 5n. Okay. So, I've taken care of that step. My restrictions have been stated. Again, the rule is I can say everything in terms of m, or I can say everything in terms of n, but you don't have to do both. So, here's the cool thing. First of all, do we all agree that first expression is off limits right now?
Yes.
Do not touch. Okay? Cannot, this is off limits. However, everything in the product, in the multiplying part, is a fair game. You can cancel. So is there some canceling that happens?
2m minus n.
2m minus n. I can either do it here or with this one, but why don't we just stick in the same one?
Yeah.
Okay? Anything else?
Oh, another 2m minus n.
There's another 2m minus n. Do you get that? Recognizing this now is going to make life so much easier in the next step.
Yeah.
If you don't cancel and now you move on, you guys get my denominator is going to be huge, because now you're going to have the whole point of this is to do these cancelings so that you don't have 5 or 6 things in your denominator as your common denominator, right? So let's see what we've got. We've got 5m minus n over 2m plus n. Take away numerator 3 bracket m plus 5n, and denominator is 2m plus n times 3m plus n. Okay, so take a look at your denominators. I'm subtracting now, so I need a common denominator. So I need a denominator that 2m plus n will divide into. I need a denominator that 2m plus n times 3m plus n will divide into.
Just multiply.
3m plus n.
Do I even need to adjust? So so do we agree the second expression is good to go?
Yeah.
And we've seen that numerically too. Do you remember seeing questions like, what's a half minus a quarter? You don't need to adjust the quarter. You just need to adjust the half to make it so that it works with the quarter. Do you know what I mean? You just have to go 2/4 minus, I don't have to change this, right? So that's kind of what's happening here. I don't have to change this, but I have to change my first one so it has the same denominator. So this one just has a 3m plus n missing, so that's what I'm going to multiply by. So I'm going to write it as a single. Everyone okay? Single expression. The common denominator is going to be 2m plus n times 3m plus n. 5m minus n is already there. What am I going to remember to do with this? You put it in as a package in brackets, and I need to multiply it by 3m plus n to make this work. I am now just going to copy the numerator of the second piece. So that is my single expression I now need to simplify. Okay? Now, are we going to expand the denominator? No. Never. Don't do it. Don't expand denominator. So I typically, as I go through this process, I typically always start by just recopying the denominator, factored, and now I need to expand the numerator, because again, I keep pointing out, do you all recognize why the numerator is currently not factored? The subtraction here, right? So the only way that this is the worst way to leave something. It's like some factors minus some other factors. That's nothing. That's not expanded. That's not standard form. It's not factored form. It's gross form. It's like, ugh, I don't like it. Okay? So we at least need to get to standard form. We need to at least expand this. Okay? So let's do the expanding. 5m times 3m, 15m squared. 5m times n is 5mn. Negative n times 3m is negative 3mn. So overall, plus 2mn. Negative n times n is negative n squared. Okay, minus 3m, and then don't do all the hard stuff and make a mistake here. What's the last term I'm writing? Minus 15n. Okay, now here's the cool thing here. Are you done?
Yes.
Yeah, you're done. There's nothing you can do. Okay? If there had been mn's and n squareds or something here, then yes, clean it off and see if you can factor, but it's not happening here. Yeah?
So you then boil for the first two, and then you just expand to the second?
Because the monomial, yeah. It's about whether or not you're distributing a single or a double.
But if it was all three of them in brackets, you would just boil all three?
Yes, but there's a separate, it's like, there's a separate expansion happening here and a separate expansion happening here because of the subtraction.
That was an intense.
Intense?
Just
An intense one-page lesson?
multiplying and dividing better.
Of course, everyone likes multiplying.
But so you just get to possibly not.
When you
Like sometimes you're
Okay.
left with like a ton of things, and then you're like, that was great.
Yeah, so, okay, so here's the plan for tomorrow. So first of all, your goal tonight is to complete the assigned work at the bottom. The more you practice, the better you get at it, right? I think you get that that's the key to this unit. You just need to do the work and practice so you get very comfortable with doing it. If on the test you have to go stare, now what do I do next? It needs to be, I've done so many of these, I can just go right to town and just do each step one at a time, and I'm not having to really struggle to say what happens next. So the key to being able to do that is to have done the homework. So your goal is to have completed, the adding, subtracting homework. Tomorrow, we'll take up some questions. I think there might have been a couple I didn't get to yesterday, but I think hopefully you gave them a try again, because I think I tried to give you a hint on the last two multiplying dividing ones. What we'll do tomorrow is, it'll be take up questions. I will have a show what you know, but it'll be one of those things where I'm not probably going to collect it. It'll be more, I'll send you the solution, you can check yourself. Your homework over the weekend will be to do the review for chapter 2, or I'll tell you, I think I wrote it at the bottom. Did I write the bottom of the page? No. I'll write tomorrow on the board when we do the test checklist. We'll do the test checklist tomorrow, so you have an idea of what to expect on the test. On the test checklist, I will tell you what questions you should do from the review section in this unit, and that should be your homework this weekend, as well as going through any questions you didn't get the first time. I would go through and try those ones again in your note from your notes. Monday we'll be answering any questions from review, and if there are none or we're all happy, then I will be ready to go to start the next unit. Okay, but it is a shortened class because of PLC on Monday, and then Tuesday is your test. I currently don't have any plans Monday after school, so on Monday on Monday if you want. You can come after school if you have any questions as well. Okay? Yeah. Yeah.
Is there gonna be word problems?
No word problems on the test. All right.